Okay, so this question, it says let me make it a little bigger for you there. A medical researcher is comparing two treatments for lowering cholesterol, diet and meds. So it's one of the classic kind of questions. What works better to lower your cholesterol? Is it diet or medications? Or some say exercise and diet or whatever. We'll just do diet and meds. Some people say, no, you shouldn't take the meds. If you're having cholesterol problems, you should just alter your diet. Some say, no, the meds are needed. What works better? Well, let's do some study with data. Let's let data tell us. And again, these are made up numbers, so take no real life conclusions from these, but this is how you would research such a question. Here's an example. The researcher wants to see if the patients who receive the recommendation to change their diet have equal success lowering cholesterol compared to a prescription of meds. A random sample of some patients who received the recommendation to change their diet and others who were prescribed meds was taken. The results of how many did or did not lower their cholesterol are shown below. So here's the table. Let's make sure we understand this first off. That means 521 people. They changed their diet, and yes, they were able to lower their cholesterol. These 172 changed their diet, but no, they were not able to lower their cholesterol. These 564, they took meds, and yes, they were able to lower their cholesterol. And these 167, they took meds, and no, they did not lower their cholesterol, even though they were taking the meds. Okay, so we're going to do a study on this one. Now, first off, first question. For this study we should use, you can see the answer there is Z-test for the difference of two population portions. Yeah, do you see how we know that? They're talking to us in this question about you can just see that they're giving us part, right? They're saying 500. Well, first off, it doesn't say average or mean anywhere. But what we do have is we have, 521 people. It did lower their cholesterol with diet. 172 did not. So you're getting the idea of what part of the group, what percentage of the group. Whenever you're doing parts of things, you're talking about proportions. And there's two of them, right? Because we have two groups. We have the diet group and we have the meds group. So we have two groups here. So it's two proportions. That's the online calculator we're going to use. All right, let's come on in with HOH1. So if we go to the notes, by the way, here we go down to here. Here's the unit 4 notes. So if we go two proportions, that's where we're at. We're going to use the online calculator, two proportions. Hypothesis HO is P1 equal P2. The two groups are P1 and P2. HO is always equals, and then H1, P1 and P2 again, but it's going to be greater, less, or not equal. So come back and go, okay. All right, so HO is P1, P2, and this is always, HO is always equals, isn't it? But then for H1, going to have P1 and P2, but it's either going to be greater, less, or not equal. Which one? How do we know which one? Well, you go up and look for words. You look for words like bigger, smaller, higher, lower, that mean big, greater or less, something like that. So what do we see? Well, we don't really see any of those words. All we see, you might think lowering, but no. That's the whole question. What lowers cholesterol, diet or meds? That's not our comparative word. What does it say? Equal success. Let me do a better job of knowing that. Equal success. Equal. There it is. The question being put forth, the question we're trying to decide is patients who receive the recommendation to change their diet, do they have equal success compared to meds? Equal. So it's going to be, we already have equal, so then this must be, not equal. Not equal. So it's equal, not equal. Makes sense? That's what we're examining. Sorry, that's kind of scribbly. Equal or not equal. Right? So the two attorneys are saying different things. HO attorney is saying P1 equals P2. The other attorney, H1, saying, no. P1 does not equal P2, right? That's crossed out, not equal to P2. So who's right? Who's got the evidence? We're going to go to the calculator and see. So, all right. So how we can do that? Which calculator? We already said two proportions. So let me show it to you. Well, I'll show it in a minute, but basically when you go there, let me just write out what we're going to see. When you go to the online calculator, the two proportions, what you're going to see is it's going to say sample size. And it's going to say number of successes. Sample size and number of successes. And then over on the side, it's going to go like first group, second group. Got to put those in. So how do we do that? Well, if you look at the chart here, remember what is success in this case? What are we trying to measure? We're trying to measure success is they lower their, oops, spelled it wrong, cholesterol, right? Do they lower the cholesterol? So what's the sense? So, and what are the two different groups? Well, there's the diet group and there's the meds group. How did I come up with that? Why that order? That's just the order they mentioned in the problem right there. Diet came first, then meds, right? So the first group is diet, the second group is meds. So the question is, what's the sample size for the diet group? Well, for the diet group, we're going to have to add these up. This will be 693. I just added up this number and this number. 693. That's the total number of people in the diet group. 693. And how many of those were successful? 521, right? They were yes, they lowered their cholesterol among the diet group. Okay, and then what about the other one? I'm going to add up these numbers as well, like this and this. So I don't know what that's. 1, 3, 1. I think it's 731. Is that right? 731. Yeah. So 731 total. How many were successful? 560. So these are the 564 of them were successful in lowering their cholesterol. See how I'm coming up with those numbers? Again, sample size is the total number in the sample. For the diet group, add up the two diet numbers, 693. For the meds group, add up the two med numbers, 731. Number successful, that's how many did lower their cholesterol. That's both the yeses. Yes, they lowered their cholesterol, the 5. Whoops, different wrong. It's these two. It's the 521 and the 564. Okay. Put those in the calculator. I'll show it in just a minute. And then we also need to do a couple of the radio buttons. And the radio buttons that we need to select is we're going to have the choose the not equal because that's from H1. We always just grab whatever's from H1 right there. And then we're going to choose the one that says pooled. Let me show you where I'm getting that idea. Comes up down here. Whoops, here's the notes. Let me show you the notes. So the notes say if you're doing two proportions, that's what we're doing. For hypothesis test, choose P1 greater, lesser, than equal, matching H1. That's why I say we just get it from H1. And then the radio button, pooled, right there. That's what I did. I'm going to choose pooled and not equal, which is matching H1. And I'm going to put in these numbers, 521, 693, just like that. Let's do it. So we go here. Where's the two proportions? It's number 19. Here's the calculator, number 19. Go to two proportions. We're going to go, okay. So this is 521, 693, I believe. I'll go back and check. So yeah, 521, 693, and 564, 731. 564, 731. 564, 731. There we go. Get all the numbers in there. Now I got to do the radio button. So over here, look, I'm going around the radio buttons. Which one do I want? I want not equal. And then I want pooled. See this radio button here? Pooled. You calculate. There we go. We care about the Z and the P. There's the Z, there's the P. Minus 0.874 and P is 0.3819. Copy and paste those on back. And there they are. We've already got them here. There's the Z. Well, it is negative. And there's the P. All right. So now it's time to draw a conclusion. Does diet work better? Meds? Are they equal, not equal? What's the story? How do we draw our conclusion? Well, remember, it's all about comparing the p-value to the alpha level. That's always the key way to end. So what's the p-value? Well, I've got the p-value right here. 0.30, oops, scribbly 8 there. 3820. The alpha level's up here somewhere. There's alpha 0.1. 0.1. So which one of those is greater? Obviously 38. 38 is greater than 0.1. So yeah. So and then what's our saying? Our handy dandy saying that we memorize to conclude these. If the P is low, then the HO, the null, must go, meaning go away. So that's the saying you want to have memorized and say to yourself every time you finish a hypothesis test. If the P is low, the null must go. If the P is low, the null must go. So is our P low? Here's the p-value. No, it's greater. It's greater. So our p-value this time is certainly not low. So then you got to add nots here. Not and not, right? Because it says if the P, let's go back to the original statement. If the P is low, the null must go. But if the P is not low, the null must not go away. And that's us, because our p-value is greater. It's not low, it's greater. So if the P is not low, then the null must not go away. So there's our conclusion. The null must not go away. What does that mean? The null must not go away. That means HO, we fail to reject, right? It's not going away. We're not rejecting it. Not go away. Don't reject it. Fail to reject it. If you're failing to reject it, then you're keeping it, aren't you? You're keeping HO. You're failing to reject it, and you're keeping it. You're keeping it. And so that's how we get, greater here, fail to reject. Now, a lot of students ask me, Mr. I don't know how to get those last two. Let me help with that. That all comes, these last two, come from either HO or H1. In our case, they're going to come from HO because we're keeping HO. So it means you go back up here, here's HO. Oh, I should have written, let me go back and write it. HO is always weak evidence. Every time. HO, every hypothesis, weak evidence, and H1 is always strong evidence. So it's just like a court of law, right? Zero comes before one. You start with HO. What do you start with? When a criminal case, when the accused person walks in the room, the judge will, if you ever on a jury, judge will instruct you to assume the person is innocent. So you're going to assume that the person is innocent unless evidence is strong. So HO, we assume the person is innocent. Oh, sorry. My thing's moving all around on me. Try that again. There we go. So yeah, so we come up here and we assume the person is innocent. And if evidence is weak, if there's not strong evidence, you'll just stick with that assumption. Just stick with HO. The person is innocent. But if there's strong evidence, you'll go with the other option, H1. Okay, so what is it in our case? In our case, we're keeping HO. So let's go back and make sure we're clear what that means. We go back then to HO. Keep HO, keep HO. Here's HO. We're going to keep exactly what HO, what does HO say? Weak evidence, and P1 is greater, or is equal to P2. So we just write exactly that. Weak evidence, P1 equal to P2. See how I came to that conclusion? Weak and equal. How did I do that? Again, I just simply took exactly what happened. I'd start with if the P is low, the null must go, but our P was greater, it was not low. So if the P is not low, the null must not go away. So if the null is not going away, then I'm failing to reject the null. I'm keeping the null. So then I go, okay, so it's whatever the null says then. The null is always weak, and P1 equal P2. Weak evidence, P1 equal P2. So our conclusion is that the success rates in learning cluster for patients who change their diet is equal to the success rate for patients who do meds. Our answer is they came out pretty much equal. Diet or meds came out pretty much equal. That's what the evidence showed on that. And so there we go.